So we are given the question that there is a string S and we have to return the longest palindromic substring. So let's break it down. First of all, what's a palindrome? It's easy. Any string that is same when read from the left hand side or the right hand side. So some examples might be AA or ABA, even ACCA. These are all palindromes, and I need to find the longest palindrome that is present in the given string S. Okay, so let's take this example. We have BA, BD. So let's start from B. What is the maximum length I can get? Maximum length palindromic substring I can get, that is BAB. Starting from A I can get ABA, that's 3. From B it's just B, that's 1. A it's 1, D it's 1. So the length is 3 and there are two choices. I can either get BAB or I can get ABA. So I can return any of these substrings here. Okay, what is the constraint given to me? The constraint is the length at max is 1000, and string just consists of digits and English letters. It can either be lowercase or an uppercase. Okay, let's see how we can approach this problem. Let's try. Let's say I do not know that it is a DP problem or whatever. I'm just given a string. The string is, let's say, A, B, C, C, B, A, and D. This is my string. Now I need to see what is the maximum length substring in it. I have one approach, that's the brute force approach. I can always do. Brute force will be something like I start from A and I find the maximum palindromic substring possible from here. That is going to be how much? I can always take the substring from I to J, that will be order n, and checking that will be order n again, right? So what I can do is, if I go AB, I have to check the entire string, not just B appended. That's not a very good solution. What is the complexity I will get? For each index, starting index I am going till J, and this is taking me time O of J minus I. Let's type it, it's getting difficult here. So A, B, 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 C, C, B, A, D. For each I am going till J, and this will take me time O of J minus I. First of all, just to construct the string. I can use a linked list to append the last character that gets added. In that case, it will take me O of 1 time. That's fine too. Now I need to check whether it's a palindrome or not, right? Palindrome or not. So that will take me time proportional to the size of the string, that's J minus I. So I'll do this for each J and for each I. Let's say I is 0. So this will be done for each J. So that will be 1 plus 2 plus 3 till n. That's n square. Similarly, when I is equal to 1, I will have 1 plus 2 plus 3 till n minus 1. That's also n square. So this is a cubic solution, right? So this is O of n cube. And why is it so? For each I am doing n square operations at max. O of n square operations at max, right? So that means n into n square, that's just n cube. And that's not a very nice solution, but because our constraints are of the power 10 raised to the power 3, right? Yes, 10 raised to the power 3, and this will mean something of the order 10 raised to the power 9, and we take to be granted on lead code OJ that at max or 10 raised to the power 7 is acceptable within 1 second. These many operations a computer can perform within a second. Okay, so we need to somehow improve this algo and come up with something better. What can be done? I have a string from I to j. Can I use that? Let's say I'm just thinking about DP now. How can I use the information given to me so far to conclude something about the last index I? Let's say I have a string, and let's make it to A. This is my I, let's say, and I know everything that I need to know about these things. That is the first thing that we need to understand. We are the Brahma, so as to speak. We have created the universe before I, and we know each and everything that there is to know about the substring S0 to I minus 1. Okay, so what I can do is and the second thing is we have to define a state. So define a state, right? Defining a state is I can define the state as that dp of I will have the maximum length palindromic substring ending exactly at I. Okay, so let's say I know that the maximum length substring ending at C, I know what it is. That's cool with me. I go till CC, that's the maximum palindromic substring. Now I see A. Can I match the character just before CC? That will help me expand my substring. So that character is B, and that is not possible, right? It's not possible now. That is cool too. Can I do something else? Is it possible? Instead of A, just make it B now. That's getting, yep, make it B. And I see that I can match B with this B, right? So I can extend the palindromic substring that earlier had just CC. Now it will be B, C, 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 B. That's one thing. What if I had some palindromic substring in between this CC? That is, some substring was there. This CC was not just CC, but it was something like A, B, C, something, something here, then C, B, A, D, and we had one B here, and it was not B, let's say. In that case, the longest palindromic substring ending at C is this one, but I'm getting a and let's say that this is the only B that is present in this interval. This is the only B. If I'm going by the thing that I got, that ending at C, I have the maximum palindromic substring that starts from C, ends at C. That's the only information that I have. Then this B will be lost, this in between B, and this is crucial for forming the maximum palindromic substring for this one, this substring B to B. So instead of just storing the maximum palindromic substring, I will have I'll store all the palindromes ending at I. So all the palindrome lengths instead of palindromes themselves, because then I'll reduce the space that I need to use up. Okay. So in the worst case, the worst case occurs when I have a substring that has this, right? In this case, at each I will have I entries, right? Because A is a palindrome, double A is a palindrome, triple A is a palindrome, and so on. This will lead me to a space of O of n squared solution. Now for the time, at each I am doing I am only looking up whatever I had in the previous entry, that is I minus 1, and I minus 1 can have at max I minus 1 entries. So for each I'll do this, so that will be equivalent to 1 plus 2 plus 3 and so on till n, and that's also n square. So I'm getting a nice O n square solution here, right? That seems legit. Now there will be a base case. We have to think about base cases now. So the base case, the first one is just length 1 palindrome. That's simple. Each character on its own is a palindrome. That's okay. And we can do this for length 2 also, right? Let's see. If I had AA, BB, C, then I'm storing my own index. So I won't be checking this BB. When I come to the second B, I won't be checking with it, right? Because this was a palindrome in itself. So I can just store that an empty string is also a palindrome. So that means the ending of that occurs after me, right? Here, somewhere here, and that is 5. That's null, matlab. So that is one trick I can use here. That's a neat trick, I would say, but yeah, this makes our solution a bit better. That's it, right? Okay, cool. Let's start coding it now. Let's take the template from here. And the base cases are always important. So int n is s dot size. First we'll get the size of the string. Let's say the size is 1 less than 1, it's 0, so it's just that. The answer is that only. And if n is less than or equal to 1, then we just return that string. So return s. Otherwise I have to construct a dp. So it is going to be a vector of ints, and we can call it, let's make it a better name, max length palindrome. So max length palin is the name, the size will be n, and we will keep pushing the values when we need to, right? So now we need to initialize this palin. The first thing that we need to know is that the characters on themselves are a palindrome. So for each I'll store I, okay, and I'll also store I plus 1. Why I plus 1? Because the null string that occurs here in the cavity between A and B is also a palindrome, so that when I come at B and I look the max length palin data structure of A, the vector that is stored here, I see that this cavity here is a palindrome, so that I can get a chance to compare this B and this A for a length 2 palindrome. This will be helpful in cases where I have repetitive words, like repetitive characters like BB. So in this case, this cavity is a palindrome, this b gets compared with this b and we store the answer as 2 here, right? Okay, so for int I equals 0, I less than n, I plus plus, I will have a max length palin at index I will push back what value? Will push back I first of all, and we'll also push back I plus 1, right? Yep. Now when this is done, we are going for a length of 2 at least now. So for int length equals 2, length will be at max n, right? Less than or equal to n, and length plus plus. For int I, now I have to choose the starting point, right, or the ending point. When the length is 2, if I get a starting point, then I know the last character that I have. Or can I do it in a better way? Let's see. I plus length is my last character, na? Let us see. It's not about the length, man. No, we need to get this thing back. I'll start from index 1. 0 is done. From 1, I will see whether I can do something better with whatever I have, and I will push that thing in my array. Yep. Okay, so for int I equals 1, I less than n, I plus plus, we'll start from the last one, and that is just what we need, right? So just the last whatever values are there. So for int j equals 0, j less than max length palin whatever I minus 1 had, j plus plus, and we'll see if whatever that value was, whatever index it had, right? This is the index that it had, minus 1, the index just before that, if it is within the array bounds, that's the first thing, and the value there. So the value will be s of max length palin I minus 1, j minus 1. If this value is equal to what I have at I, if this is the case, then sure, I can just push this in my current palin data structure, push back, and the index will be the same, that is max length palin I minus 1, j minus 1, that's it. And at each point I'll take the maximum that I can get, so it will be int max length is 1 to start with, and then I will be like for int j equals 0, j less than max length palin I, j plus plus, and max length, let's get it over. Max length is max of max length, and what I had max length palin for index I, and the jth one entry, that is the index, and the length will be I minus this, plus 1 because the indices are inclusive, and I can just return max length, right? Okay, let's go through the solution first and see how it performs. So I get the size here. If the size is less than or equal to 1, if it's 0, it's null. If it's 1, return that. We get this data structure to store. Let's comment out now. Store all the starting indices of palindromes ending at index I, right? For each I. Okay, so for I, this is the character itself, and this is the void, so that the next equal char can be accommodated. Now max length is 1 in the starting for each index except 0, because at 0 I can only get a maximum length of 1 that I got. I can do it from 0 as well, there is no problem, because I'm checking the bounds in this line. For j0 to, then this will fail, right? I minus 1 will fail. That is the reason we are not doing it here, and the solution is pre-computed as well. It's j plus plus j0, and this is the last one that we have, the entry in I minus 1. We'll go through each entry and check if that index, this is the index. So let's make it even better now. Okay, so int, let's call it last, or yeah, last index is probably suitable naming for this one. So this will be this minus 1. So we'll check if the last index is within the bounds, and whatever I have at the last index is equal to what I have at I. If it is, then we just push the last index here. Yep. And for j0 max palin I, we are just looking at the maximum that we can get. That's it. Okay, I'm not testing it for now. Let's just, but it's always a good idea to test your solution. Let's see if it works. Okay. What did we do wrong? Max. Okay. Size, man. What? This is a very, this is not a good thing. Size. Yep. Okay. This is a very, no. So here we are going for the maximum length palindrome, not the length. We need to store the string as well, right? String max palin string. For starters, it can be a 0. Now we need to check if this gets increased. So if max length is lesser than I minus max length palin I j plus 1, then we need to update the max length accordingly. That's I minus max length palin I j plus 1, and we need to update the string as well. So that's max palin string equals, so we are going to use substring function here, and this will be as dot sub str. This is starting at this index, right? Max length palin I. Okay, just calm down. It's starting at max length palin I j. That is the starting point, man. That is what you are storing, right? And it is going till the max length. Yeah. Okay. And we'll return max palin string here. Okay, what happened now? Okay, this cannot be 0. I forgot, this has to be a sub str, so remember this thing, that is a character and it cannot be assigned. Okay, it's passing. Let's take some crew test on some different example. It's passing. Let's take an empty string. This had to be done by your own, so it's expected that it's not 0. Let's take just one. That's also a valid input. Actually you have to do it uh, by hand, not here. It's just for the demo. Seems okayish. Let's do on AB. Yep, it seems okay. Let's get it accepted. Okay, cool. So that's okay. When did I try? Okay, it was a long time back. Cool. So here it got accepted. That's, I think, the question got accepted. That's it. But what we could have done better was, first thing was I didn't take care of the return type. That's a major mistake. The second was I didn't take care of this size. Syntax is important and I need to be diligent in doing that. What else? Apart from that, everything is good, I guess. Okay, let's see in the next question what we can do.